All right, welcome to 4.4 day 2, and we're just going to do more factoring, right? So we got a couple more cases today. You can kind of see them here up on the screen. Before we do that, just question, what is factoring, right? Maybe good review things here. What does it mean to factor? What is factoring, and what is a quadratic? Right, that's what we're doing in this section is factoring quadratics, but what do those two words mean? So pause the video and see if you can figure it out. All right, so factoring means to break it apart, like the reverse of multiplying. So if say I had like a simple 2x plus 6, that expression, if I pulled the times 2 to the front, that'd be like the reverse of multiplying, and that's called factoring, right? And that's actually called a GCF factor where you pull it to the front. So factoring just means to like break it apart. Quadratic is a polynomial that's has an x squared. So like there's different names. X to the first is linear, x cubed is a cubic, but x squared is called a quadratic, which again is really weird because quad you think means 4, but in this case it really just means x squared. All right, so a couple extra special cases today to factor. All right, a general thing is when you factor, you should always look for a GCF first. That should always be your first step. And then there's going to be different situations. So we covered this one yesterday where he had 3 terms and they multiplied to this 12 and added up to 7. So it factored to like x plus 3 times x plus 4. Right? And then today's lesson, we're going to cover 2 new parts where, like on B here, we check for GCF, but there isn't one. And then there's still this 3 in the front, so we have to factor it with what's called like decomposition or factor by grouping, I guess is what we'll also call it. All right, and then the last case is a square minus square case, and we're actually going to start with this part today. All right, so it is helpful to know your perfect squares. So if you want to make a list here, pause the video. I'll do the first 2 for you, but see if you can pause it and do that next. I don't know, up to like 13 squared if you remember it. Pause the video, give it a shot. All right, so 4 squared is 16. And then I'm just going to start listing 25, 36, 49, 64. I'm going to skip 64, 81, 100. And then 121, 144, and 13 squared is 169. Right? So those are helpful in identifying that it's square minus square. Right? So like this case is called a squared minus b squared. And how it works is you can actually imagine it like 0x is in the middle. So if we took this first one and said, okay, it's like the case where it's 3 terms, where we can make it into 2 little binomials with x and x, and then they have to multiply to negative 100 and add up to 0. So it would be 1 negative and 1 positive, and it would be, in this case, 10 and negative 10. Okay, so as weird as it seems, this little binomial actually breaks into 2 linear binomials like that. And it basically is like the square root of the x and the square root of the 100. All right, so if we take a look at this other one over here, this is one students often forget, but if you think it through, we need y and y here to make y squared, and then to make a negative 1, if you do plus 1 and minus 1, it'll work, right? Because 1 is on our list of perfect squares. And again, just to make sense of this, these two things are equal. If we were to, they don't look equal, but if we were to FOIL, we'd have y squared minus y plus y, and then minus 1. And so these would cancel out, and you'd have y squared minus 1. So y squared minus 1 is definitely equal to those two things multiplied together, right? And once you get the hang of it, it shouldn't be too bad. These are a little bit more tricky ones because they're not just x squared. But I could think about a GCF first, see if there's any GCF. So think about that, try these, and then unpause the video. No GCFs for either one of these, right? And all these are on our list. 25 and 49 are squares, and like 16 and 81. So it's a good chance that we're factoring with this case. Okay, and so all that's different is we're going to make 2 little binomials, but instead of x and x, right? We got to think what would make 25x squared, right? So that's where our square roots will help because it's 5x and 5x, right? And then to make negative 49, we need one positive and one negative, and then 7 and 7, just take the square root, and boom, we're there. Okay, second one, two little binomials, 16x squared. So again, think what do we need here to make 16x squared? So 4x and 4x. And then the square root of 81 is 9, so we need plus 9 and negative 9 in the back part. All right. So a couple of tricky cases, and normally I give away candy, but I can't give you virtual candy, I guess. So this is a real common mistake. Is students see this and say, okay, this is the square, x squared and 16, so I'm just going to factor it to x plus 4 and x plus 4 because the 16 is positive. And they think, oh, that's what it's going to factor to. But why is that wrong, right? So if you get this right, next time you're back in school, you can ask Mr. Webb for some candy. Say he owes you. Okay, so the reason or the problem with this is these aren't equal, right? If we were to FOIL this and check, we would have x squared, and then we'd have a 16, that's true. But in the middle two terms, we'd have a 4x and let's see, another 4x. Okay, so it is not the same as x plus 16. Those two things are not equal, right? In the other version, it's a minus between them. So if it looks like that, then you can do x plus 4 and x minus 4 because the middle two terms are positive 4x and negative 4x, and that makes the 0x in the middle. Okay, so basically this one does not factor, right? The case we're doing is specifically square thing minus square thing. And if you have a plus between them, if there's no GCF, then it generally won't factor. Okay, so that's kind of a tricky case. All right, so this turtle is going to eat this strawberry. And if you can do that, then you can do this challenge one. So give this one, factor one, a quick try. All right, what's different here is these aren't square numbers. 3 and 75 aren't perfect squares. But hopefully we realize GCF, right? That can be pulled out first. And then we have square minus square. All right, so once we pull out the 3, we can leave it out front. And then we have x and x to get the x squared. To get minus 25, we do negative 5 and positive 5. And there you go. There is your factorization of that. Okay, so the final case we're going to do is like kind of this long factor. So it's a trinomial again. So see if I have an example here. Yeah, so here's a perfect way to explain it is yesterday we did starting with just x squared. And when we were factoring there, we could kind of just do this quick method where it, do x and x for the x squared and then multiply to 10 and add to 7. All right, and once we find those two numbers, boom, we're done. Okay, so what we're going to do today is, what if it isn't, right? So in this case, it's 6x squared, and so now it becomes way more complicated, right? Because would you do like 6x and x, or maybe you would do 3x here and 2x here, or maybe the reverse of that, 2x here and 3x here, right? So there's all these different possibilities, so it becomes a much, much harder question, all right? And you can kind of do guess and check to figure it out, but I don't recommend that, right? As these get harder, that's going to be a pain in the neck to do that guess and check. Okay, so what we're actually going to do is sort of reverse the FOIL process by at the end of FOIL, you always combine like the middle two, right? Like if I was FOILing these over here, I'd have x squared plus 2x plus 5x plus 10. And then we combine these middle two to 7x. Okay, and so we're going to do the reverse of that by starting by splitting this 7x, right? But we got to figure out, do we split it to like 2 and 5 or 1 and 6, or how do we split it up? Okay, and so to figure that out, you actually start in this long process. You start by doing 6 times 2, Okay, and then make your list of things that multiply to positive 12. So it could be 2 positive or 2 negative. In this case, they want to add up to positive 7. So the 2 we need is right there. All right, so we're going to split 7x to 3x plus 4x. And it's literally like this other step in reverse, right? When we do FOIL, it's reversing that process. All right, then the other two numbers just come down. So 6x squared is just going to come down here. And then the 2 is going to come down here. All right, and it doesn't matter. You could reverse them. You could put the 4 here and the 3 here. 4x and 3x. It doesn't matter what order. All right, once you get here, we're going to group. So this method is sometimes called factor by grouping because at this point you group the first two and group the last two. Okay, and now pull out GCFs. So from these front two will come a 3 and an x. Okay, and then we'll divide that out. So divide by 3, take out an x. So that's going to leave us with 2x. Divide by 3, take out an x. So that's going to be a 1. And then back here, they're both divisible by 2. So you can pull out a 2. Leaves us with 2x plus 1. All right, and then the final step. So just like we factored into two binomials here, we're going to end up with two little binomials that are equal to two little binomials multiplied together that are equal to what we started with. And so they come from this little part here that matches. So that's one of the factors. Okay, and then whatever is in front is being multiplied with that factor. So we just combine that to a single factor, 3x plus 2, and that's our answer. Right, so that's called long factor or factor by decomposition. Right, so it's kind of a long process, but once you get the hang of it, it's actually pretty slick, and it goes pretty good. Usually I find the hardest part for kids is to find this number here, especially as the values get bigger, but make the list for sure if you get stuck. Okay, so let's do one more like this. Okay, so I'm going to let you give it a shot. And if I forgot to mention it in the last video, I would always start with GCF. So look, or the last problem, sorry. I would start for, is there a GCF? And in this one, there isn't, right? Because maybe we could pull the 2 out front and we would be able to avoid the whole long factorization. But, in this one, there's no GCF. 2 doesn't divide 9 or 5 evenly. So we got to do our long method. Okay, and that again starts by multiplying these two. Okay, so now we need one negative, one positive. If we're going to multiply to negative 10, and they add up to the middle one. So negative 10, positive 1. All right, so we're going to split this up like that. So I'm going to put negative 10x here, plus 1x. Okay, and notice that that is equal to negative 9x, right? If we added those together, it'd be equal. All right, and then bring down the other two parts. So 2x squared and minus 5. Okay, now we're going to group these two, and then take out GCFs. So from the front, we can take out a 2 and an x. So divide it out, so we have 2x in front. That leaves us with x and minus 5. Okay, and back here, there is no GCF, but we can still take out at least a 1, right? Because just pull the 1 to the front. Okay, and if you do this right, these two parts will match. So that's a good sign that they match. And so our two factors are whatever's in front. So 2x plus 1, and then the matching x minus 5. Okay, and that is our. Okay, and then the only other thing I really want to mention here is make sure to check for GCF. So like this last example looks like it would be a long factor question because of the 4. But if you actually realize that all of these are divisible by 4, you can pull that to the front, and then you don't have to long factor. You can pull the 4 to the front, and then you get x squared minus 6x plus 9. And then you might say, oh, now I have x squared here, so now I can just figure out what multiplies to positive 9 and adds up to negative 6. Right, and so you can factor this remaining part into x minus 3 and an x minus 3, right? And so you still have the 4 out front, but then you can avoid the long factor by pulling out the GCF. All right, hope that helps.